In this video, we're going to talk about amines, or amines, or amines. There's many ways to pronounce this. But the basic fact is that amines are derivatives from the ammonia molecule. So, if we take ammonia and we make it into its condensed form, we're going to see that we have a nitrogen atom bonding to only 3 different hydrogen atoms. This means that we have a chance to substitute these hydrogen atoms for different chains. What happens when we substitute one of the hydrogen atoms? We have a primary amine because we only have one substitution. If we substitute 2 of them, we're going to have a secondary amine. Amine, I'm going to draw amine here as well. And if we substitute all 3 hydrogen atoms, we're going to get a tertiary amine. Tertiary amine. So, let's begin with very simple example of IUPAC nomenclature, okay? So, in this case, where we only have 1 carbon, our longest chain, again, that includes a functional group, is only 1 carbon long. And my functional group is the nitrogen atom. This could also be drawn as NH2. But again, as your teacher, it depends on how everybody's teaching you to show this bonding. So my longest chain is methane. But when we use IUPAC names, the E is substituted for the whole world. Not world, I'm sorry. The whole word. Amine. So this is going to become methanamine. When we have more complex examples, we're going to start having numbers and locants to identify the type of amine that is present. So in this case, we have the amino group with 2 carbons. So then this is what? Ethane is my basic chain. I take away the E and this becomes ethanamine. Okay? Now, let's do another shape. 1, 2, 3. And another shape. 1, 2, 3. So here, both of them have 3 carbons attached to the amino group. However, this is a structure of isomer. It has the same functional group, but the naming should be different because the N atom, the nitrogen atom, is attached at a different location on the chain. So if we want to give the amino group the lowest number, I'm going to begin here in this chain, 1, 2, 3. And here, 1, 2, 3, or 1, 2, 3, it's the same thing, 2, 3. It's based on the molecule of propane. So remember, we take away the E and we add the word amine. Propanamine. And here we also have propanamine. So what is the difference? That here, the amino group is located at number 2. So I add the number 2 at the beginning. And here we add the number 1, or depends on what your teacher says. You might not have to add the number, assuming automatically that the nitrogen group, the amino group, is at the first carbon. So propanamine. Just like in alcohols, an alternate naming style in IUPAC can be used, which is propane 2 amine, or propane 1 amine. So remember to ask your teacher which is the most appropriate method of naming. What happens when the nitrogen atom is in the middle? Where you're going to start to run into other naming issues. So let's draw one that's like this. We choose our longest chain. Here both of the chains are the same length. So I'm going to choose 1. And what's going to happen? I'm going to draw number 1, number 2. This shouldn't have numbers with the name because it's obvious that it's attached to either 1 or 2, so it would resonate, it doesn't matter. So this one would be called ethanamine or ethanamine. But how do we call the rest of the molecule? What's attached and where is it attached? On this side, we have 2 carbons bonding to the nitrogen. So the locant It's not going to be a number. It's going to be N. Big N. Big N, and at N we have an ethyl group. So this would be called N-ethyl ethanamine. Now let's try this again. If we know how to draw it, N-ethyl ethanamine. So ethanamine tells us we have 2 carbons attaching to a nitrogen atom, and then N-ethyl tells us that at N there's an ethyl. As you can see, I was able to redraw the same molecule, meaning that the name is a proper IUPAC name. Let's try another more complicated example. This is a tertiary amine, and again we have to choose our longest chain. My longest chain is obviously this side chain that's right here, and then we have these attachments on the sides. So first let's name the last part of the chain. So it's 3-propane propanamine, or propanamine. However, this is attached at number 1, and it would make a difference because we could also have this shape, and this would be 2-propanamine. So here we do have to add the number 1-propanamine, and then at N we have methyl, and at N we have methyl. So we would write the locant twice to tell us where it is, separated by a comma, di to indicate we have 2 of the same type, and N-dimethyl propanamine. And that's it.